Hi everyone, so today I'm going to teach about chapter 2 number bases. So today lesson will cover 2.1 number bases with the learning standard. Represent and explain the numbers and value bases in terms of numerals, place values, digit values, and number values based on the collection process. So today we'll cover numerals and place value and we'll cover a bit about digit values. Next, I have some question with you how we need to use number bases in our daily life. So actually, just now we have the grouping activity. So is related to our number bases. So number bases are based on grouping, or we say that it's collection process. So in base 10, we group every 10 objects. In base 5, we group every 5 objects. So in the activity just now, we group every 5 books for the area. And the next one, different situations use different bases. Okay, for information, not all the systems will use the base 10. Actually, we are always familiar with using the base 10, but there are some systems that do not use base 10. So, for example, the computers. So, computers will use the base 2. It means that it use the digit 0 and 1. And also, the digital clocks will use the base 60 for time. So, for example, like when the minutes cover is 59 minutes, after 1 minute we jump into 00. So and then the hour will plus 1. So it means that it's best. So that's how we use the number bases in our daily life. So next we turn into our subtopic here. We represent the numbers in various bases in terms of numerals. Numerals means that it's a type of symbol, group symbol. So the symbol here is digit. So the number bases there are 2 up to top base 10. So I will cover a bit. Okay, let's say base 2 they have a digit of 0 and 1. So actually the digits for each number base will have starting from 0 until until the digit that is less than its base. So for example like the base 2 0 1. And then so for example like just now the alien counts the numbers of books is base 5 0 until 4. Okay, it does not exceed 5. Okay, it only until 4 does not exceed the base. Okay, so next is some reminder. So remember the definition of the digits. Just now we have said about the digit. So the definition of the digit is the symbols used or combined to form a number in the number system. So for the decimal number system, where we have 10 digits to be used, so 0 until 9. So how do we count? How do we count the digits? So for example, the 2145, there are 4 digits. So how do we count this? So 1, 2, 3, 4. So there are 4 digits here. Next, I will explain about the example. So give 2 examples of the numbers that represent the numbers in base 2 up to base 10. So this is the solution here. So just now I said that the number bases, the digit does not exceed the number base itself. So the example for the base 10, the base 2 is 10, 1, 0 base 2. So 1, 0 does not exceed does not exceed the number 2, the base itself. Same with other example, we look at base 8, 1, 7 base 8. So 1 and 7 are the digits does not exceed 8. So just remember, write down the base at the below. Okay? Or actually, we no need to write down the base 10 at the below because we usually use base 10 in our daily life. Okay, next, when some tips, actually I have mentioned this again and again. So each base has digits from 0 to a digit which is less than its base. So for example, the base 2 has only digits 0 and 1. Next, how to read the number bases. Okay, just now I have read the number bases, right? So, okay, this 32, the number is 32, and the base is 5. So how do we read this? It's read as 3, 2, base 5. 3, 2 is the number. We no need to read as 32. Just 3, 2, base 5. Wait, base. Don't forget about, you need to put a phrase, a word base here. Okay, next we have the next subtopic. Represent the numbers in bases in terms of place values. Just now is in terms of numerals. So now we learn about place values. So place values in our base 10 system, we already know that ones, tens, hundreds, thousands. This is the place values actually. But how about the place values in the number bases? Okay, so starting from the base 10. Okay, base 10, we have ones. How do we get ones actually? So we have the form of a to the power of n. So a to the power of n, it means that a is the base, n is the power. So base 10, 10 is the best, so we replace the a with 10, we get 10 to the power of n. And then the power, the number of power of n, starting from 0 to infinity, but we will not cover too large number, because if infinity too large is too large number. So for the base 10, a to the power of 0, it means that 10 to the power of 0. Okay, 10 to the power of 0, we will get 1 actually. Okay, we will get 1. And then 10 to the power of 1, we get 10. 10 to the power of 2, we get 100. 10 to the power of 3, we get 1000. Same thing with the other. So that's why we read the place value like ones, tens, hundreds, thousand, and so on. Then we look at maybe some other number bases. So for example, like base 4. So base 4 is starting from a to the power of 0. So it means that 4 to the power of 0, we get 1. 4 to the power of 1, we get 4. 4 to the power of 2, we get 16. Yeah. Same goes with the other number bases. You can have a look. Next, we have some recall. Okay, so the bases, just now I have mentioned a is the base. Okay, a is the base, and the n is the power. N is the power. So for example, like this one. Okay, for example, we have a to the power of a. Okay, a to the power of a, it means that sorry, a to the power of 4. So it means that this one, a multiplication with times 4 times. 4 times of a will get a to the power of 4. Okay, so we'll get 4 times of a, we get a to the power of 4. Next, we will have the example. So stack the place value of each digit in the numbers below. So we look at the part A. 6231 8 base 8. So the base is 8. Actually, for you easier, you can draw a table like this. Numbers in base 8. So we write down the number 6231, and then we write down the place value here. Okay, place value we starting from we write down the base. The, the first one is the base. Write down the base here. Okay, the base is 8. So we write down the base 8 from this box until this box, and then so until okay, so we need to write the power of each base. So we're starting from 0, 1, 2, 3. So I will suggest you to write down the place value starting from the unit the right hand side first, the right hand side first until left hand side, because you can write down because you can starting to count it, starting to count from the right hand side 0, 1, 2, 3. So 8 to the power of 0, 8 to the power of 1, 8 to the power of 2, 8 to the power of 3. So same go with the part B. 1, 1, 1, 1, 0, 1, 1, 1, 0, 1. Okay, that's all the numbers, the base value. And then you can have a look at this. You get the answer, the place value like this. Okay. Next, we need to stack the value of a particular digit in a number in various places. So we need to know how to stack the particular digit so that we can turn into the next subtopic. Okay. So there are two methods here: multiplication of digit place value and use of place value block. The left hand side is about the calculation. The right hand side is about the visualization, so that you can count easily. So look at the first method here, multiplication of digit and place value. So you can write down number, you can write down the place value just like before, and then you add on one column here, digit value. So the underlying one is the one, that's the number one here. So the place value is 2 to the power 1. So digit value, it means that this value, what is the value of this number? It means that like this. So this digit is one of the 2 to the power of 1. It means that one unit of 2 to the power of 1. So we just 1 times 2 to the power of 1, we get 2. So it means that this digit that has the value of 2. And maybe we can use the visualization one, we can use the block. Okay, we just write down the number plus value. Okay. So for this method, we're starting from, look at the place value here is 2 to the power of 1. So it means that you can draw two blocks here too. Two blocks here first. And then you say that the number 1. The number 1 is one unit of this. One unit of 2 to the power of 1 block. So you just draw one time. So actually it's same goal is like this, because they also 1 times 2 to the power 1. But this one is the visualization, we can see easily. Or maybe it is too difficult to understand. I will explain the next example like this. Okay. So for the second example is 2012 base 3. So the underline is 2. We know that the place value is 3 to the power 3. Okay. Don't forget we write down the place value starting for the right hand side first. 3 to the power 0, 3 to the power 1, 3 to the power 2, and 3 to the power 3. So this number 2 has the place value 3 to the power 3. But how about the digit value? So we draw the block 3 to the power 3. So this one is the 3 to the power 3 block. Actually, there are 27. Okay, 27, you can count this. And then it said that it has two of the 3 to the power 3 units. Block, sorry. So it means that there are 2 units of 3 to the power 3 blocks. You just write down, you just draw the 2 of it. So you can calculate it by doing the addition. 3 to the power 3 plus 3 to the power 3, if you get 51. Actually, it's 2 times 3 to the power 3. So you have the calculation here. 2 times 3 to the power 3, you get 54. Next, we have some example. Actually, same goal with this concept here. Okay, so the next, so stack the value of the underlying digit in each of the following numbers. So this one we have 3, 4, 1, base 8. So for example, like the underlying digit is 3, so it means that the place value of this is this. Okay, we call this one. 8 to the power of 0, 8 to the power of 1, this one is 8 to the power of 2. So the place value of the digit 3 is 8 to the power of 2. So what is the value of this digit? So it means that it's 3 times 8 to the power of 2. Okay, we look at the answer. Like this. We can just scroll down the table like this, numbers, place values, and then the digit value. Okay, simple with this concept. You can draw the table like this. Okay, this is easier for the understanding. So I will not explain about the B, C, and D because they're sample with the same method. And then that's all for the today lessons. So before I end the lesson, so I will give you a video that is about how do we use the calculator um, to convert one base to another base.